everyone, welcome back to another video on our algorithm series. And today we're going to be solving an algorithm, a really popular algorithm actually, called the palindrome checker. And so this algorithm is one that's run across a lot of times when you're learning how to code. And let's actually read through the instructions together right now. So this problem wants us to return true if the given string is a palindrome, otherwise we have to return false. And for those of you who don't know what a palindrome is, it's a word or sentence or string that's spelled the same forward and backward, ignoring punctuation, case, and spacing. And so basically, we're going to have to remove all the non-alphanumeric characters from this string, and we're going to have to check to see if it's a palindrome. And so for this problem set, I solved this particular algorithm maybe 6 months ago. And today, actually, we're actually going to go over two different solutions for the same problem, because as many of you may know, even though you get the problem right, that might not be the most efficient way to solve a problem in programming. And so the first approach I'm going to show you is the solution that I came across maybe 6 months ago. And the newer solution is a much more performant solution, an optimal solution for this algorithm. And we're going to be going over both as well. And so let's get right to the problem. So before we check and implement the palindrome algorithm, we're going to have to remove all non-alphanumeric characters from the original string. And so let me just pull this up right here so we can check to see. Okay, so let's create a variable here. Let filtered string, it's going to be equal to string dot, and we're going to have to, we're going to have to use the replace keyword here. And for this problem, in order to remove all non-alphanumeric characters, we're definitely going to have to use a little bit of regex. And for those of you who don't know what regex is, you guys can always look it up here online on MDN docs. You can MDN. You could always look it up. And basically, it's basically a set of conditions here we're going to have to put into the replace in order to filter out whatever we don't want. And let me just do it really quickly here for you guys. Alrighty, here. So in the regex, we're going to have to filter out everything that's not. So this is the not operator, not 0 through 9, A through Z. And then we're going to have to also flag this with GI. And so this should be working. So let's console.log filtered string. Perfect. So this is the regex here that takes out all non-alphanumeric characters. And basically, we also have to lowercase the string as well, because we don't want to worry about the casing in this particular problem. We just want to check to see if the letters or the numbers are matching. So let's also add a to lowercase here as well. To lowercase. Perfect. So this should be working. Let's actually check to see if it is. Yeah, but I think it is working here. So we have a completely filtered string here that should be good to go. And so let's actually get to the real algorithm here. So the palindrome, check to see if the reverse word is the same as the original filtered string. So how are we going to do this? There's plenty of ways we can do this. We can use a for loop, but I'm going to opt in for some string methods that are common. So right now, I'm just going to reverse a string in a very simple manner. So let's do const. We could actually do a const here too. Let's make that a constant. Const reverse string is equal to filtered string dot split dot reverse dot join. And so this one right here, the console.log reverse string, this should also be the same exact word if it is a palindrome. And here we're going to filter out the non-special characters and basically check to see if this one, the filter string, is equal to the reverse string. And in order to do this, it's pretty simple. We're just going to do a little ternary operator. We're going to return is filtered string equal to reverse string. True, otherwise false. And so this algorithm right here should work, and it does. So this was a pretty fast algorithm right here. It really only took us a couple minutes, not really that difficult, especially if we remove the console.logs. And it seems like a simple enough algorithm right here to say this could be the optimal solution. But as you're looking at this problem, there could be edge cases where this particular code that I wrote here is not really the most performant in terms of the O and time space complexity. Pretty much saying that this algorithm right here could take longer to perform than if we wrote it in a different way. And what do I mean by this? For example, let's say the string right here was not just the word I, but it was the whole book of Harry Potter thrown into this function palindrome here. Then if we're gonna have to check to see if this is a palindrome, we basically have to filter out the entire string. Well, we have to do that anyways, but we have to basically reverse the entire string, split the entire string into arrays, reverse every single character, and join it all back together. And after we do that, then we have to compare to see if this is equal to this, if the whole string is equal to a whole million character, billion character string, and then we return the final result. So in this particular algorithm, we don't know if it's a palindrome until we go through the entire string. And although it doesn't really matter for a small use case like this, if you're throwing in all 7 novels of the Harry Potter book, we're not going to really know if it's a palindrome until we loop through the entire 7 series of Harry Potter. And so let's actually I've actually come up with a better algorithm recently for the same problem set. And that's what I'm going to show you right here. So let's comment this out right here. So we have a solution. So let's call this one first solution best approach for edge cases. Yeah, because most of the times you're not going to throw in a billion character novel into this function, but you never know sometimes. And so the new solution that we're going to come across is going to be much more optimal, because what we're actually going to do is we're going to loop through the string and check from the end of the string to the beginning of the string and check to see if there's equality there. And we're going to loop to the middle of the string, and basically if any character along that comparison does not match, it's not a palindrome. And let me show you what I mean there. So first one, we're obviously going to have to filter the string anyway, so let's just take that code back up here. And so here the algorithm we're going to do is compare end of string to beginning and move towards middle. If any char is not equal, we will return false, otherwise true. And so right now you guys might be wondering, how is this more optimal? What are you saying? I'm a little confused, but we'll get to that right now. And so let's create a variable here called front, and we're going to make that equal to 0. Let's make another variable called back, and we're going to make that equal to filter string dot length minus 1. And so we're going to have to use a loop here, and the best kind of loop for this particular scenario is a while loop. While front is less than back, so while the front part and the back part are not at the middle yet, we're going to keep looping over. So while front is less than back, basically the condition we're going to check for is if the filtered string of front is not equal to filtered string of back, we're just going to return false. Else, in every other use case, then we're going to say front plus plus, back minus minus, and we're just going to continue on in the loop. And so basically, when you're looking at this algorithm right here, we're basically saying, okay, we're going to start at the front of the string, and we're going to start at the back of the string as well, because we're looping with the while loop. And we're basically checking each character along the loop from front to the middle and from back to the middle. And we're checking for equality between each character. And if any character does not equal the other character, then it's not a palindrome. For example, if we're in a Harry Potter book, we're looping through 7 series of Harry Potter, and we're at the front of the string. If the front of the string is an A, and the back of the string, the end of the 7 series of Harry Potter is a character G, we're only comparing one character and saying, does A equal G? It does not. So the whole algorithm stops executing and we return the correct answer. And this is actually a much more performant algorithm, because once we get to the end of the array, then yes, we're going to have to return true. And so let's actually test the solution first. And that solution also works the same as the other one, but it's so much more performant. Not just in the fact that we're checking each character along the way, and if any character does not specify a condition, we're stopping the execution of the function, but also because you're only looping half the time, because if you're looping from front to the back and back to the front, the array size or the string size is only cut into half. And so basically this algorithm, in theory, can be infinitely more performant than the first algorithm that we solved here. Because if we had a string, let's say, and had trillions and trillions of characters, if we wanted to use this solution, we'd have to split all trillion characters, reverse it, and join it all together. And we won't come to the solution until we split, reverse, join the entire string. But in this algorithm here, we know for a fact that if any character along this trillion character string is not equal to the other side of it, then it's a false palindrome. And so that's the algorithm here today. And from now on, I'll probably be going over algorithm solutions and not just giving one solution, but giving a kind of easier solution and a different way to kind of think about it, so that you guys can solve much more performant algorithms for yourselves. And so thank you so much for watching our videos. Just know that the GitHub for a bunch of different algorithms is going to be posted in the bio. And so you can check that anytime you want. If you have any recommendations for any algorithms that you want me to solve, feel free to leave a comment or direct message me, and I'll be happy to solve it for you. Thank you so much, and see you next time.